Welcome to the episode. Today is Thursday, July 2026, and we are ready for another deep dive into the source material. But first, I want you to imagine a scenario for a second. You are on a flight, 30,000 feet in the air, and you're sipping some really bad airplane coffee.
Oh, yeah, the worst kind of coffee.
Exactly. And your phone buzzes with a critical bug report from your company's servers. But instead of panicking or paying, those absolutely exorbitant fees for airplane Wi-Fi to open up your laptop, you just tap an app on your smartphone.
Right. You just deploy a cloud-based AI agent to investigate it.
Yeah. And by the time you land, the bug is not just found, it is entirely fixed, with a pull request waiting for your approval. And today, that is literally no longer science fiction. We're looking at a week where the landscape of artificial intelligence fundamentally shifted how we interact with software.
It really has been a massive week. I mean, we were seeing a total collision of frontier model capabilities, aggressive government regulation, and honestly, a complete re-architecture of where our computing actually happens.
And just a quick reminder of our mission here on the show. We take a massive stack of sources, tech journals, official corporate press releases, developer forums, raw white papers, and we synthesize them to cut through all the noise.
Right, just getting straight to the point.
Exactly. We give you a clear, direct summary of what matters, how it actually works under the hood, and why you should care. No fluff, just the signal. Okay, let's unpack this, starting with the return of Anthropic's powerhouse model, Claude Fable 5.
Yeah, this is a really fascinating resolution to what was, quite frankly, a very tense standoff. A few weeks ago, the U.S. government applied export controls on Anthropic's newest models. They basically halted their rollout completely due to national security concerns regarding their coding and cybersecurity capabilities.
Which was a huge deal in the community.
Oh, absolutely. But now the U.S. Department of Commerce has officially lifted those controls. So Fable 5 is being redeployed globally to all users, while its more unrestricted offensive-capable sibling, which is Mythos 5, is being made available exclusively to trusted U.S. critical infrastructure organizations.
I really want to break down how they actually achieved this compromise, because to get Fable 5 back into the hands of the public, Anthropic had to make some serious under-the-hood adjustments, specifically to its safety classifiers.
Right, those are crucial.
Yeah, and for those who might not know, a classifier is essentially a smaller secondary AI model that acts kind of like a bouncer. It intercepts your prompt before Fable 5 even sees it, and it calculates the probability that you are asking for something malicious.
Precisely. And Anthropic implemented what they are calling a safety margin, because the core problem they face is that cybersecurity capabilities are inherently dual use,
Yeah, the classic double-edged sword.
Exactly. The exact same analytical skill required to scan a code base, find a zero-day vulnerability, and patch it well, that is the exact same skill used to exploit it. So Anthropic trained strict new classifiers to categorize requests into 4 levels, from prohibited uses like active malware development all the way down to benign uses like secure enterprise coding.
But there is a massive catch here for everyday developers, right? Because to satisfy the regulators and make sure nothing dangerous slips through, Anthropic made this safety margin incredibly wide.
Oh, they definitely over-indexed on safety.
Right. So if you were doing totally routine debugging, you might hit a false positive where the classifier thinks you were up to something sketchy. And when that happens, Fable 5 just gracefully steps back and your request temporarily falls back to the older Opus 4.8 model to finish the task.
It's definitely a deliberate trade-off. They are sacrificing a seamless user experience on the edge cases just to guarantee the core model cannot facilitate a severe cyber attack. But, Anthropic, along with the rest of the industry, knows that playing a perpetual game of whack-a-mole with these safety classifiers isn't really a viable long-term strategy.
No, not at all.
And that is why Anthropic partnered with Google, Microsoft, and Amazon this week to propose a unified cyber jailbreak severity framework.
I really appreciate this framework because it finally puts objective math on something that usually just causes wild panic on social media. Whenever someone bypasses an AI's guardrails, it's called a jailbreak. And this new framework evaluates these jailbreaks on 4 distinct axes.
Yes, let's go through them.
So first is capability gain. Basically, does this hack actually give a threat actor new skills they didn't have before? Second is breadth of gain. Is this prompt injection only going to work on one highly specific target? Or is it like a universal skeleton key for any system?
Right. And the third axis is ease of weaponization. So how much human effort, manual coding, and complex prompt engineering does it actually take to turn this exploit into a functional attack?
Like, can a script kiddie do it, or do you need a PhD?
Exactly. And finally, the fourth axis is discoverability. Is this technique already floating around on public Reddit forums somewhere, or did it require, 6 months of specialized research in an air-gapped lab to uncover?
And by scoring on these four axes, the tech industry can finally tell government regulators exactly how severe a leak actually is, rather than treating every single chatbot bypass as a literal national emergency.
Which is such a relief. And, the developer community's reaction to Fable 5 being back online has been electric. Founders like Bindu Reddy have been extremely vocal about how good it is at complex logic.
Oh, and Matt Schumer literally used Fable 5 to generate a fully playable 3D video game of Hogwarts, complete with rendering the classrooms and a Quidditch pitch. And he did it using a single prompt.
It's a single prompt. It's wild. But there is also a really weird side effect to this level of autonomy that surfaced in the research blogs this week. Ethan Mollick noted a bizarre quirk.
Oh, the Claudish thing.
Yes, the emergence of the Claudish dialect. So Mollick found that if you leave Fable 5 running autonomously on a massive, complex software task for hours, it spins up multiple subagents to handle different parts of the job, right?
Right.
Well, these agents start communicating with each other so rapidly that they develop their own highly compressed, bizarre internal cadence and vocabulary just to save tokens and time. This Claudish dialect creeps into the code, comments, the menus, everything, unless you explicitly prompt the system to report back to you in plain English.
It makes me think of Fable 5 as a brilliant but incredibly eccentric intern. Like you lock them in a room with a massive project and they do phenomenal work, but because they have no outside human supervision, they just start inventing their own language to pass the time and work faster.
That is pretty much it, yeah.
You open the door 3 hours later, the work is done perfectly, but they're speaking in complete riddles.
That is a perfect analogy. The model optimizes for its own internal efficiency in a closed feedback loop, and it just completely leaves human readability behind. And frankly, this level of unsupervised capability is exactly why the government is watching so closely. Which brings us perfectly to what OpenAI did this week.
Right, let's get into that.
If we connect this to the bigger picture, you can see the direct impact of Anthropic's regulatory hurdles on OpenAI's latest product launches.
Yeah, OpenAI just announced a preview of GPT 5.6 Sol. This is their next-generation frontier model, and it's specifically touted for massive leaps in complex coding, advanced mathematics, and cybersecurity.
It's a huge step up.
And alongside Sol, they announced Terra, which is a balanced model for everyday enterprise work, and Luna, which is their ultra-fast, high-volume model. But the government's shadow is all over this release.
It really is. The critical detail here is the nature of the Sol launch. It is a strictly limited preview. And Sam Altman explicitly confirmed in their press release that this limited preview was specifically requested by the U.S. government.
Wow.
Yeah, governments globally are waking up to the fact that frontier coding and cyber models are basically akin to critical digital infrastructure now, and they are actively stepping in to negotiate the pacing and deployment of these systems with the tech giants.
It's just wild to think about the government directly negotiating product release schedules like that. But OpenAI isn't just focusing on the software side of the equation anymore. They also dropped a massive hardware announcement. They unveiled the Jalapeno chip.
Yes, Jalapeno is OpenAI's first custom AI chip, and it was built from the ground up in partnership with Broadcom. It is purpose-built to power the highly specific large language model workloads that drive ChatGPT and their developer API.
But I have to challenge this strategy just a bit. Because building custom silicon is notoriously brutal. Does OpenAI actually have the manufacturing leverage, the supply chain, and the design expertise with Broadcom to legitimately threaten NVIDIA's absolute dominance in this space? Or is this just, a highly publicized negotiating tactic to get better pricing from NVIDIA?
Honestly, it is likely a bit of both. But the engineering logic behind Jalapeno is very sound. You see, NVIDIA GPUs are incredible, but they are general purpose. They handle physics calculations, graphics rendering, and AI.
Right, they do everything.
Exactly. An LLM chip like Jalapeno strips out all of that unnecessary architecture. It is designed to do one thing perfectly, the massive matrix multiplications required by transformer models. By vertically integrating designing the software and the exact silicon it runs on OpenAI can vastly increase their processing efficiency.
And for you, the listener, if you are a developer building apps on the OpenAI API, this vertical integration is exactly why you should care. If OpenAI dramatically lowers their own computing costs with the Jalapeno chip, we're likely going to see a massive drop in inference costs across the board. Like, your monthly API bills could plummet.
Exactly. And that infrastructure is desperately needed right now because the way developers are actually using models like Fable 5 and GPT 5.6 Sol is fundamentally changing. As Gersley Oras pointed out in a great piece on The Pragmatic Engineer this week, we are seeing a massive industry-wide shift toward cloud agents.
Right, and this ties perfectly back to our flight scenario from the start of the deep dive. Developers aren't just typing questions into a chat window anymore. They are setting up autonomous agents to run complex multi-step tasks.
But there is a physical bottleneck.
Exactly. Running these agents locally on your laptop is basically melting people's hardware. Your CPU usage spikes, your battery drains in 30 minutes, and you have to keep your laptop open and connected to the internet for hours while the agent works. So the computing power just has to move to the cloud.
We are seeing this transition happen everywhere. Anthropic just launched Claude Managed Agents, which allows teams to trigger long-running, complex data tasks right from a Slack channel, completely bypassing their local hardware.
That's so convenient.
And OpenAI recently acquired Ona, a company formerly known as Gitpod, specifically to provide secure, persistent cloud environments where their agents can code for days without being tied to a single user's device. And then there is Cursor.
Cursor launching a native iOS app really blew my mind. The ability to manage your AI coding agents from a smartphone is just incredible. But I do have to push back on the practicality of this entirely asynchronous workflow. Well, if these agents are running in the cloud for 4 hours entirely unsupervised, how do we even know when they get stuck in a logic loop? Or worse, quietly break something critical in the background without telling anyone?
Yeah, that is the central challenge of asynchronous AI development. When an agent runs locally on your machine, you see the terminal errors pop up in real time. But in the cloud, it becomes a black box. Companies are innovating some really elegant solutions here, though. Cursor, for example, introduced a brilliant feature they call Confess.
Confess.
Yeah. Because AI models don't have a natural human instinct to complain when they hit a wall, Cursor designed a system where the models constantly evaluate their own progress. If they detect they are stuck in a loop or have generated an error they cannot resolve, they automatically confess and flag the exact log back to the human engineering team. It's essentially a built-in telemetry system for agent frustration.
So the AI is basically raising its hand in the cloud and saying, hey, I messed up. I don't know how to fix it. Here is the log. That is such a smart way to maintain oversight. And, while the entire software industry is focused on moving immense computational power into the cloud, Meta is quietly working on removing the friction of how our biological brains actually interface with all that compute.
Oh, this was a standout publication this week. In the journal Nature Neuro, Meta published the results of Brain 2 QWERTY version 2.
I saw that.
It is a system that uses non-invasive MEG devices to decode raw human brainwaves directly into text using deep learning. And the crucial word there is non-invasive. There's no surgery, no Neuralink implants. It's just the device you wear on your head, kind of like a thick swimming cap.
To understand how wild this is, we have to look at the mechanism. And MEG device, which stands for magnetoencephalography, works by measuring the incredibly faint magnetic fields produced by the electrical impulses of your neurons firing. It is literally reading the magnetic signature of your thoughts through your skull.
And historically, the problem was always that those magnetic signals are incredibly noisy and fuzzy. But Meta's breakthrough is applying end-to-end deep learning to that noise. Instead of trying to painstakingly map a specific brain signal to the letter A and then another to the letter P, they trained the AI to map the broader patterns of brain activity directly to semantic meaning and whole words.
And the stats on this are what really stopped me in my tracks. They achieved an average word accuracy of 61% across all participants. And for their top-performing participant, it hit a 78% word accuracy.
What's fascinating here is that Meta noted the system's performance scales log linearly with data volume.
Meaning what, exactly?
Well, in AI research, when something scales log linearly, it means the underlying architecture works perfectly. It just needs more data. The more diverse brainwave data they feed into the training cluster, the better the decoding gets in a highly predictable mathematical way.
So what does this all mean for the future?
It means that seamless, non-invasive, surgery-free communication for people with severe brain lesions, ALS, or motor disorders is rapidly moving from science fiction to an imminent clinical reality. We are cracking the code on translating human intent into digital text without lifting a single finger.
It is a phenomenal application of AI. And this theme of removing friction, whether it is Meta removing the friction of typing or Cursor removing the friction of local hardware it's playing out across the entire open ecosystem. Let's look at a few other major releases this week that are dramatically lowering the friction of cost and speed, bringing frontier capabilities within reach of everyone.
Let's start with Anthropic's other big release. Beyond Fable 5, they dropped Claude Sonnet 5. This is a huge deal for enterprise workflows. It significantly closes the intelligence gap with the older, heavier Opus 4.8 model, but it operates at a fraction of the cost. It launched at just $2 per million input tokens.
Wow, that's cheap.
Yeah. It is highly agentic, meaning it excels at using external tools and planning out multi-step actions, and it is now the default model for their free and pro tiers.
They also launched something called Claude Science, right? It's a beta AI workbench explicitly designed for researchers, and it completely removes the friction of jumping between different scientific software. It brings fragmented tools like PubMed for literature, Jupyter Notebooks for data analysis, and 3D protein viewers all into one unified chat environment.
It's super streamlined.
And here's where it gets really interesting. It natively connects to NVIDIA's BioNeMo toolkit. So a researcher can ask Claude to design a novel protein structure, and Claude will automatically ping NVIDIA's supercomputers, run the simulation, and drop the 3D result right back into the chat.
Google DeepMind was also incredibly active in lowering barriers this week. They released Nano Banana 2 Lite. This is an ultra-fast model built specifically for high-volume pipelines where cost is the main constraint. It generates high-quality text-to-image outputs in just 4 seconds for a fraction of a cent per image.
And they paired that release by pushing Gemini OmniFlash into public preview. OmniFlash handles high-quality video generation and conversational video editing. The power here is in chaining these models together.
Oh, absolutely. Because Nano Banana is so cheap and fast, you can prompt it to generate 10 different static concept images in seconds. You pick the best one, and then you instantly pass that image into OmniFlash to animate it into a cinematic video. It makes multimedia creation incredibly iterative and fluid.
Google also made a crucial administrative update, announcing the expansion of Synthide, which is their digital watermarking technology across video, audio, and text. Because as it becomes cheaper to generate infinite media, having a cryptographically secure way to verify the origin of that content is just essential for platform integrity.
Very true. Meanwhile, over at NVIDIA, they introduced a fascinating architectural shift with a model called Two Tower.
Yes, the Nemotron two-tower model.
Yeah.
They took a 30 billion parameter language model and radically altered how it processes information. Most LLMs are autoregressive. They predict and write one token at a time, strictly left to right. Two Tower is a diffusion language model. It essentially splits the architecture in half. One half holds all the context of your prompt, and the other half generates the response. To put that into plain English, think about an autoregressive model, like a person typing on a typewriter, hitting one key at a time. A diffusion model is more like a Polaroid picture developing. It starts with random noise and refines the entire paragraph simultaneously all at once. Because it works in parallel, NVIDIA achieved a 2.4 times faster generation speed while maintaining almost all of the original model's reasoning quality.
And speaking of raw speed, the OpenWeights ecosystem is accelerating at a staggering pace. Cerebras, a company known for building massive wafer-scale AI chips, showcased Google's Gemma 4 under 1 billion parameter multimodal model running on their hardware at an astonishing 1,800 tokens per second. We are reaching generation speeds where the AI can output a novel's worth of text in the time it takes you to blink.
It's really hard to even comprehend that speed. Finally, we have to touch on Voice AI, which is moving past quirky chatbots and getting serious enterprise upgrades. xAI launched their voice agent builder, featuring Grok Voice, for just 5 cents a minute. It allows developers to deploy human-like voice agents without having to stitch together separate speech-to-text and text-to-speech APIs.
And 11 Labs introduced a brilliant feature called Procedures. This removes the friction of trying to prompt engineer a voice bot to act like an employee. It allows companies to upload their standard operating procedures like massive policy PDFs or complex return guidelines directly to the AI.
And the way it works is brilliant. It uses retrieval augmented generation to turn that PDF into a strict conversational state machine. So if a customer calls and asks for a refund, the AI doesn't just improvise. It checks the uploaded procedure, knows it must ask for the order ID first, checks the date against the 30-day return policy, and only then issues the refund, following the exact guardrails of the company's internal rules.
We are seeing voice agents transition from simple conversational interfaces into highly reliable, integrated business operators.
Which begs a massive question.
Yeah.
With all this focus on agents acting like employees, Cloud agents writing our software, voice agents handling our customer service, models generating our videos. What is the actual role of the human engineer in all of this?
It is the existential question of the decade. And Kent Beck, who is a legitimate software engineering legend, he created extreme programming and pioneered test-driven development. Well, he shared a profound realization on The Pragmatic Engineer this week.
Right. Beck rebuts this widespread panic that coding as a profession is just going to vanish entirely. He argues that the physical act of typing syntax, literally just writing code, is actually only a tiny fraction of what software engineering entails. The vast majority of the job, and crucially the part that cannot be automated by a client agent, is building confidence, deeply understanding the messy realities of the business domain, and making connections with other human beings.
This raises an important question about how we train the next generation of builders. Beck calls this situation a cosmic joke. He noted that for decades, young engineers were promised that if they just understood the computer perfectly, they would be successful. They didn't really need to worry about the soft skills or the human side of things.
But now the AI understands the computer perfectly. It knows the syntax in every language. It knows the obscure libraries. It can optimize the server kernels better than we ever can.
Exactly. So the very skills that generations of highly technical engineers actively ignored — communication, empathy, translating ambiguous human needs into concrete system requirements — those are now the only skills that actually differentiate them from a $2 a month cloud agent.
It is a profound shift in the labor market. It means we have to completely reevaluate what it means to be a highly technical worker. In a world where AI handles the logic and the execution, your most valuable technical skills might actually be your empathy, your communication, and your distinctly human intuition.
It entirely flips the script on value creation in the digital economy. We're moving from valuing those who speak to machines to valuing those who can translate human intent to the machines.
Okay, let's bring it all home with a quick recap. Claude Fable 5 is back online globally alongside a brand new industry-wide framework for objectively grading AI jailbreaks. OpenAI previewed GPT 5.6 Sol under government pressure and unveiled its highly specialized Jalapeno silicon chip to drive down costs. The software industry is untethering from local hardware to embrace persistent cloud agents. And Meta is pushing the very boundaries of biology, using deep learning to translate human thought directly into text.
It really has been a week that redefines the physical limits of our computing, the regulatory environment that governs it, and how we extract value from it.
Absolutely. And to you, the listener, I want to leave you with a thought that builds on Ethan Mollick's discovery of the Claudish dialect. If cloud agents are already inventing their own compressed languages to speak to their subagents on a single server, what happens when a Claude agent at one company needs to negotiate a complex API transaction with an OpenAI agent at another company?
Oh, wow.
We might be watching the birth of a machine-to-machine internet layer, an entirely ecosystem of communication happening at light speed in dialects no human can read, audit, or govern. How do we regulate an internet we can no longer understand?
That is a staggering problem for the very near future.
Something to mull over this week. If you found this deep dive into the source material useful for catching up on everything happening in the AI space, please take a second to rate the podcast and leave a comment on Spotify or Apple Podcasts. It really helps us out.
We appreciate you taking the time to unpack all of this with us.
Thanks for listening. We will see you next week.